Hey guys, welcome to Tuesday's Math today. We're going to be doing our practice test on page 667. Put that page up here. What I would recommend is opening up to that page, and here's what I'm going to do. I'm going to do some problems that are exactly identical to the problems that you're going to do on your practice test today. So what I would recommend is to watch me do a problem, and then you do that problem on your assignment while you pause my video, and then play my video again, watch me do a problem, then you do the same ones. Now, there might be some that you don't need help on, that's fine. But especially if you're getting stuck, watch me do that problem that's exactly like the one you're working on, and then that'll hopefully help you solve it while it's fresh in your mind, okay? So the first ones, it's been a while since we've done this. They're going to have us graph some of these square root functions, okay? So take a look, this one here. Now, what you want to do when you graph, so you know where it technically starts, is you want to get 0 under the square root box, or a 0 as one of your solutions, right, to start. And so we want a 0 as one of our solutions so we know how far left or right to start, right? So what could I put here to give me 0 underneath this box? Obviously -4, right? And so if I put -4 there, I know I'm going to get 0. So that helps you decide, where your graph should start. Otherwise, it can be tough to get this final part, the domain and the range, right? And now once we have that, we can do any other numbers we want. We can make it easy on ourselves. We can do like 0, maybe 1, and then maybe 2, right? So if I put 0 in, now I get 4. 0 plus 4, so square root of 4 is 2, right? If I put in 1, 1 plus 4 is 5. And if I hit the square root of 5, I've got a calculator out here, and you may use one today too. You get 2.24-ish. Okay, and then if I put in a 2, I get 6. And so the square root of 6, popping that into my calculator quick, is about 2.45. So close to 2.5. Okay, and so that should give us enough info to graph, right? -4 is 0. Now we know where it starts. Okay, and then 0, 2, 1, 2.24, and then 2, about 2.5. So notice it's going to really level off and just kind of go like that, right? And so then don't forget there's 3 parts to this question. They wanted us to graph. We got that done. Compare it to the parent graph, so don't forget that. So remember, if there's something out in front, if it's a whole number, it's either going to be vertically stretched or compressed, right? If there's something out at the end, it would go up or down. And remember, if there's something underneath the square root box, it's either going to go to the left or right. So notice this one's going to go to the left, 4, right? So that's our second part of the answer. And then state the domain and range. Okay, so we can do that too. I'll do that right up here. Domain equals... Okay, now notice domain are the x values. All real numbers such that x is greater than or equal to -4, right? And your range are your y values. Now this is slowly going to go up, right? So what we'd say for range is y is greater than or equal to 0, right? It's going to go above that. And so all the numbers that are greater than or equal to 0 will be hit eventually, okay? So there's our domain and range for that one. Okay, then on numbers 6 through 9, you'll be simplifying square root expressions, okay? And so remember, if you can break down what's under the square root box, do it. Obviously, the square root of 16 is 4, so that would be brought outside the box. So 4 times 4 gives us just plain old 16, right? 4 times the square root of 16. Now remember, when you're trying to solve ones like this, okay, where you've got something going on in the denominator with a square root, you can't leave it that way, so we have to do the opposite, or the conjugate, to both the numerator and the denominator, right? So we're going to do 3 minus the square root of 5. 3 minus the square root of 5. This is very much like number 7, okay? So when we do that, we get 3 times 3 right on top, so 9. And then 3 times so you can picture a 1 being here, right? So it would be -3 times the square root of 5, right? And then over, now notice on this bottom part, we'd take 3 times 3, and that would give us 9. And then these would cancel each other out. So the bottom's going to be 4, right? So we have 9 minus 3 times the square root of 5 divided by 4. And that's your final answer. So notice the one thing that I noticed we forgot the other day was when we're multiplying, we need to take 3 times 3 on the top, but then also 3 times the square root of -5 with a 1 in front of it, right? So don't forget that step to give you this piece. And then that would probably be the only thing we forgot when we multiplied these numbers times their conjugates last time. Okay, here are some that are like 6 to 10. This is a multiplying one. Remember, when you're multiplying, we multiply together the whole numbers. In fact, this is exactly like number 9, okay? So we do get 15, and then we multiply together the square roots. Okay, and then if we can break it down, we should. Notice 12, we can break down. 2 and 6, 3 and 2. So we can pull out a pair of 2's, right? And so we'll multiply that times what's already out there. And then all that's left underneath the box is going to be the square root of 3. So there you go. There's actually number 9 for you. Then numbers 11 and 12, they want you to solve equations by canceling out square roots. The ones without variables on both sides are really easy, right? You're just going to square root both sides, or square both sides. Cross out your square root box, right? Because that cancels out. We get 10x equals 400, right? And then you can divide and solve the rest of the way. So x equals 40 for this one. That, by the way, was exactly number 11. This one's a little bit different than number 12 because I wanted you to wrestle with one of these on your own. But when there's a variable on both sides, these get a little more complicated, right? And so I'm going to square both sides right away to cancel out that square root box. So we get 2n plus 3 equals n squared. And remember, to solve these, you need to zero out a side. So let's bring both of these things over to the other side. So by taking away a 2n and taking away a 3, right? And then we can factor this. Remember, that's how we solve. So let's factor this. Can you think of two numbers that multiply together to give us negative 3 that would add up to negative 2? How about n plus 1 and n minus 3, right? And so then our two solutions, if we would solve both of those, if we put both of those 1 equaling 0, right, would be n equals negative 1 and n equals 3. So those are our two possible solutions. But then don't forget, you got to plug them in and see if any of them work. Sometimes they both work. Sometimes only one works. So don't forget to plug them in. So let's plug them both in and see what happens. So if I put a 3 in, right, in both the n spots, I get 6 plus 3. So in other words, the square root of 9 equals 3. Is that true? It is. So 3 works. That's a definite answer. Does negative 1 work? So I'll rewrite it right here. 2 times negative 1 plus 3 equals negative 1. Sorry, I should put a negative 1 there too. Okay, 2 times negative 1 gives us negative 2, plus 3 is 1. So I get the square root of 1 equals 1. Negative 1, excuse me. Does that work? Nope, not the same. Okay, and so the only solution that works for this situation is n equals 3. For 14 to 16, remember, you're going to use the Pythagorean theorem, all three of those problems, even the picture or word problem on number 16. Okay, and so I wanted to do one where a leg was missing, because I noticed those gave us a little bit of trouble, some of us, the other day. So let's fill in the pieces we have. We have 4 squared, which I can just rewrite as 16 right away, I suppose, for A. We don't have this leg, but we do have c squared. That's the hypotenuse always, right? So 21 times 21, not one that I have in my head. I should. 441, okay? So we're going to take away 16 from both sides. First of all, do that first before you try to square root both sides. Okay, I think that was our problem the other day as we were doing those out of order. So that gives us 425 on this side, b squared. And now we can square root both sides now that it's both the same. So the square root of 425 is about 20.61 or 20.62 if I rounded it off. Okay, so that would be our b side. So that's, I don't know if that was exactly like any of them, was it? No, that was just one that I kind of came up with, but you can use the same strategy of using the Pythagorean theorem to solve. For number 17, you're just going to find the 3 trigonometric ratios. I just put these on here to remind you. You might want to jot these down again if you don't have any notes from the other days of those. But again, and they want you to do that for angle A. Right? So you're going to look at this angle. And so just one example, remember sine, you can abbreviate as sin. The leg opposite over the hypotenuse. So I put in the 3 sides there. So the leg opposite of A, right, would be 4, and the hypotenuse is 5, and so on. And you can do cosine and tangent on your own. Just wanted to remind you, especially of those 3 ratios. Okay, then notice number 18. They want you to find the missing angle. Notice you don't have a couple angles. You have no idea what this is or this is. So you can't just use subtraction or something. You're going to use your calculator on this one, right? And so take a peek. If I want to find the measure of angle x, I could just type in to sine, cosine, or tangent, right, these 2 angles that I do have. Notice I have the opposite, right, and I have an adjacent side. So you look at your ratios, tangent is opposite over adjacent. Really, really important though. Remember, when you're looking for just an angle using the sides, when you type it into your calculator, you're going to do the inverse tangent. Right, because that's what you use to solve, go backwards and solve for angles, right? So the inverse tangent of 8 over 12. So we'll pop that into our calculator quick. So we'll go to the functions here, the inverse tangent of 8 divided by 12 in parentheses, and we end up with 33.69. So in other words, about 33.7 degrees, you could say. So your number 18 will be very, very much like that one. Okay, this is actually number 19 right here. I just wanted to talk through this one with you a little bit. They give you a lighthouse, and they say, how tall is the lighthouse? So notice, if I would connect this into a triangle, right, this is what our triangle would look like. So I'm going to just redraw that triangle over here. Okay, we know this is a 90-degree angle, right? They tell us that this angle is 79. They have a little buoy floating in the water that helps you find the length of the bottom of that triangle. And so we want to know, how tall is this triangle? In other words, how tall is this side, right? And so there's a way that we could use those ratios that we learned to solve that. So let's use this angle that they give us right here, angle 79. Notice we have this, what's adjacent to that angle, if we're focusing on this angle, right? And we're trying to get the opposite. And we know that tangent is opposite over adjacent, right? So we can use tangent to help us solve this. So we'd say the tangent of the angle that we're working with, right, 79, equals opposite over adjacent. So the opposite is what we don't know. The adjacent is 25 feet, right? And so remember, to solve these problems, what you need to do is get x to be by itself. So how would we do that? Well, we'd simply take 25 times both sides, right? Okay, and then we'd have 25 times the tangent of 79, which I'll let you pop into your calculator, and that'll be your answer for x for that problem. Okay, and then don't forget your label of feet. So I just wanted to make sure that problem made sense. There would be a real-life example of using these trigonometric ratios to solve a problem. You can find out the measurement of heights of certain buildings and things like that if you know the distance of things on the ground besides the buildings. And so that's really kind of a cool trick you can use to find the height of trees, or that architects can use to find the height of buildings and things like that. So it's kind of a cool real-life application of what we learned. Hopefully that gets you going on all the review problems today. Notice you're kind of hopping around a little bit. At the beginning, you're just doing 1 and 3, and then you're doing chunks here or there throughout the work. So pay close attention as you go today to which problems you should do. Have a good rest of your day. Reach out if you need help.